Okay, this video is going to be fairly short. In the slides that we have already on class pages, I've basically typed all of my notes into that first set of slides. So just to summarize, we use W equals F times D, which is work equals force times distance. And distance, we can also think of that as the change in the X direction. Something important is that movement is required for work to happen. So if an object is lifted and then carried somewhere else, only the lifting is doing work. For example, if you lift bags of groceries and then carry the groceries into the house, you're first performing work on the groceries when you lift them up, but then you're not performing any work on the groceries as you walk into the house. And that's basically the big takeaway from the beginning of work examples. When we have all of our forces acting kind of parallel to the surface, all of your work or all of your effort is going to move that object. But then in this example, if you were to push kind of just on that top corner, you're actually kind of pushing the crate into the floor, and only the horizontal component of that applied force is going to move this box. You're actually kind of working against yourself by pushing it this direction. So if you're just pushing from the top corner and pushing it along the floor, because not only are you pushing it across the floor, you're also pushing it down into the floor. So if you do have to push something that is heavy, you kind of want to get lower and more towards its center and push it parallel to the ground or parallel to the surface. When we have a force that is not parallel, so there's some sort of angle displacement, we have to work in cosine to that work equation. And there are a couple of notes on here about the different values of cosine at certain instances. If we have an instance where you're given an angle such as 35 degrees or 45 degrees, it's easy enough to just plug in the number. If you ever see that theta would be equal to 0, you don't really even have to go through the equation. Obviously, it's good for you to still check it, I guess, in case you don't remember it. But cosine of 0 is 1. So if if theta is 0, then you were just using the regular work equation. And then another note was that if theta is 90 degrees, cosine of 90 is 0. So if you see that the angle is 90 degrees, you know that no work was done because your answer would come out to be 0. I didn't include this section about net work. Essentially, it's just all of the forces times the distance times whatever angle, and that gives you the total kind of net work. Already, I think you know that work unit is joules, and then there were a couple of sample problems. There was this one about the vacuum cleaner, and then a few more later on. One thing that I had not included in the notes, which I'd like to just briefly touch upon today, and I will add this information into our notes, is that the sign of work is important. So first of all, work is positive when the component of the force is in direction of the displacement. So meaning that if you are pushing the same direction as the movement is happening, work is positive. If you are applying work in a direction that is opposite of the displacement, work would be negative. And then if the work that's done on an object only changes the object's speed without changing any direction, the sign will tell you whether the object is speeding up or slowing down. So obviously a positive would be that the object is speeding up, and a negative would be that the object is slowing down. These topics of the sign of work is something that we'll go over a little bit more in detail on Monday, and then we're also going to cover energy on Monday. So energy being, we have kinetic energy and potential energy. So I'll just combine a little bit more of a detailed lecture in our Zoom class about signs on work, and then we'll move into energy. Some other practice problems that you had from the other day, or from the notes, I think I included tugboat problem, and maybe I didn't include the tugboat problem, but I'm pretty sure I included the weightlifter problem and the shopper in the supermarket, but these answers were already on the slides anyway. I'll double check. I'm pretty, whichever one I left out, I'll make sure I add that one onto the slides as well. So at this point, if you did not finish the practice problems, you'll go back and finish those practice problems and submit them for me. Students who are in class would have just finished their test and are now going back and revising or finishing those problems as well. So please feel free to email me if you have any questions, or you can save your questions for our lecture through Zoom on Monday. All right, thank you.